Our first speaker is Dr. Pat Michaels. He is professor of environmental sciences, at the University of Virginia, where he's also the head of their climate office. He is the past president of the American Association of State Climatologists, and he's the author of numerous studies and op-eds and papers at the Cato Institute, where he serves as a senior fellow. He is also the author of Meltdown, which is a very good book, and like I mentioned, these publications are free to Hill staff. If you've not read Meltdown, I encourage you to see me after the meeting. I'll be happy to make sure you get a copy. And with that, I'll turn things over to Pat Michaels.
I am very, very upset with the way that this issue is being presented in the political discourse. If you pick up a newspaper or turn on the television, you will see that there are apparently two views of global warming. Number one, that it doesn't exist. Or number two, that it does, it's caused by people, and it's the end of the world unless we do something immediately, if not sooner. It may not surprise you that the truth lies somewhere in between. But however, claiming the truth on this seems to win very, very few friends. Just a little notion here of climate change. This is from a book published in 1972 by Emmanuel Laudruy called Times of Feast, Times of Famine, Climate Since the Year 1000. It was published at the end of an era of global cooling. People were concerned. This is the Argentière Glacier in Switzerland. Here's the little peaceful village of Argentière. And you would see this was the lateral moraine laid down at the height of the Ice Age. Obviously, the glacier was further down the mountain. Well, it was further down the mountain 116 years before, because that's when the moraine was laid down. And what do you think these people were praying for in this church during the Little Ice Age? They were praying that it went back up the mountain. And indeed, what happened was we began to burn fossil fuel. Carbon dioxide began to go up in the atmosphere. Carbon dioxide is a greenhouse gas. It absorbs infrared radiation coming from the surface of the Earth. And when it absorbs that piece of radiation, it can either re-radiate that photon back up or back down. If it weren't there, it would go straight through. One of the consequences of that, by the way, is that if you have a greenhouse effect warming, you have a stratospheric cooling. And cooling of the stratosphere has been observed for several decades, not just with relation to ozone depletion. And therefore, people who say warming in the latter part of the 20th century is all caused by the sun have a very hard problem. They have to explain how a warming sun could cool the stratosphere, which is something that you would only say if you believed if you turned the heat on a pot of water that it would cool down. Anyway, this is the annual carbon dioxide growth rate. It was pretty linear until the last few years. Some people think that might be China and India coming on board. The rate of growth of carbon dioxide in the atmosphere, however, has been much less than is generally assumed by our computer models. When we compare our computer models for common purposes, we assume CO2 is growing in the atmosphere at 1% per year. In the decade ending in 2004, it grew at 0.49% per year. In the decade ending 10 years before that, 0.42% per year. In the decade before that, 0.48% per year. So it's been relatively constant at about half the rate of increase that's the models have about twice the rate of increase that is really being observed. And that has consequences. It means our computer models tend to predict too much warming. At the end of this talk, we'll adjust our computer models for reality, and we'll see what kind of warming we get for the 21st century. Then there's the rhetoric on this issue. I do believe that this movie and book are quite responsible for the increasing polarization on this issue. And here is the way the rhetoric works. This is from the book. I have learned that beyond death and taxes, there is at least one absolute indisputable fact. Not only does human-caused global warming exist, fine. Every scientist on the planet agrees that it's warmer than it was. This is used as a rhetorical springboard for the next sentence, but that it is growing more and more dangerous. Or, quote, the planet is warming at an increasing rate. How many of you have read that? Every one of you. How many of you have not read that? It's not true. This is the Intergovernmental Panel on Climate Change's Temperature History. This was from the second assessment, or the third assessment report. The fourth assessment report has just come out. And what you see are two warmings. This one occurred here in the early 20th century because the sun got hotter. We hadn't put enough CO2 in the atmosphere to warm it. This one here is largely a result of human activity. Why? Because it takes place primarily in the coldest, driest air of the winter, which is a prediction of greenhouse warming, and it's accompanied by a stratospheric cooling. Now, you will notice that this rate has been remarkably constant. In fact, since the warming began, the second warming of the 20th century, 1975, the warming has been profoundly constant, and that is what is predicted by these computer models. That's right. They don't predict an exponential increase of warming. That is because the response of temperature to an increase in carbon dioxide is a logarithm. It's a curve that goes like this. It begins to damp off as more and more CO2 goes in. We assume the carbon dioxide is going in as a low-order exponent, and you add up a logarithm and an exponent, and it's very easy to get a straight line. And that's what nature did for us. Nature has integrated the response of carbon dioxide, temperature to carbon dioxide, and come up with the functional form that indeed is the logical functional form, namely a straight line. Something for you to take home from this talk, by the way. Anyone who says the planet is warming at an increasing rate is deadly wrong. The rate is obviously constant. I'm a member of the IPCC, by the way. People sometimes ask that, proving that all garden parties need skunks. Now, what I'm going to do here is I'm going to step off from this talk for a minute and show you something a little bit disturbing about the science of climate change and how the current issue developed. These are our three temperature histories. I'm sorry, yeah, okay. These are our three temperature histories that we have, and I'm going to take you back to 1995. Let's say it's 1995. The blue line are the surface temperatures from the United Nations Intergovernmental Panel on Climate Change. The green line are weather balloon temperatures between 5 and 30,000 feet in the atmosphere. And the red line are satellite sense temperatures published by Spencer and Christie. Now, as you can see, this is pretty darn equivocal. And that led a lot of people to say, well, there are two records, the satellite and the weather balloon, that really aren't showing very much. And there's a surface record that shows this warming here. The balance of the data suggests that there is a problem and that probably is not warming at the rate that the surface temperature says it is. Well, now we'll go to 2000. And what's going to happen in 2000 is that the IPCC is going to issue another temperature history that is going to revise the blue line. I want you to see what happens to the blue line in the year 2000. Look at the beginning of the period. All of a sudden, the temperature drops. This is the same data that went in. And we have the big 1998 El Nino. Still, the satellite doesn't seem to show anything, nor does the weather balloon seem to show anything. By the year 2005, the IPCC revised the temperature record again. The weather balloon data was reanalyzed with the notion that there may be some errors resulting from instrumental changes, particularly in the tropics, and the satellite was discovered to have an orbital drift that probably masked a warming in the record. And so Spencer and Christie, the satellite people, revised their records. The weather balloon record got revised, and the surface record got revised again. I'd like you to pay attention to what happens to these. The surface record is now even colder at the beginning of the temperature record. The weather balloon record has dropped massively at the beginning of the record. This has caused a lot of ferment in science because the people who did the IPCC record were asked, staffers, listen to me, were asked to supply the raw data. And the response came back. We're not supplying the data. This is to a scientist in England because the reason you're asking for it is you're trying to find something wrong with it. Ladies and gentlemen, that's what science has sunk to on the issue of global warming. Now, let me go back to where I was here. Sorry about this. Okay, I'm going to just spend a few minutes talking about some of the common exaggerations about global warming, the melting of Antarctica. Every computer model that we have in the modern generation tells us Antarctica would be either neutral for ice in the 21st century or would gain ice, for obvious reasons. You warm up the ocean surrounding Antarctica a little bit, the water vapor in the atmosphere increases, and if you converge to that moisture over the Antarctic continent, what do you think it's going to do? Rain more? No, it snows more. Howsoever, this is the rhetoric that's painted. This is from Gore's book, The Second Canary in the Coal Mine is Antarctica. And then he shows the break-off from the Antarctic Peninsula of some of these ice chunks. For size purposes, I was very pleased to see that he showed what a small area of Antarctica this is. Because we actually have temperature records from around Antarctica published by Duran in 2003. And nobody disputes these. You notice these are the cool colors here, and you can see the net temperature change averaged over Antarctica is negative. That's right. This is well known in the scientific community. Over here on the Antarctic Peninsula, there's that one little hot spot. And so all the news stories that you see that say Antarctica is melting are almost all from the Antarctic Peninsula. Nobody bothers to tell you that this comprises 2% of Antarctica. And the tip of the peninsula comprises 1/2 of 1% of Antarctica. And the entire region, when averaged across, in fact, the temperature is going down. There are several reasons this might be true. I can cook you a hypothesis right here. This ocean is warming up a little bit. There's more moisture being converged over the continent. The clouds that form the snow that would increase the ice on Antarctica reflect more radiation than they absorb coming from the surface. They are net coolers. So, in fact, the cooling of Antarctica could, in fact, be a consequence of a slight warming of the surrounding ocean. Here's a piece of information that got a tremendous amount of press about a year ago. It's from the GRACE satellite. The GRACE satellite begins to take data, note the axis there, near 2002.5. That's the middle of 2002, and the record ends in 2005. This is the West Antarctic ice sheet. This is the East Antarctic ice sheet. I think I've got them right. I might have flipped them around. Anyway, and what you can see, be careful here. There's one piece of data here that is separated from most of the rest of the data set. If I were a reviewer of this paper, I would have said, I don't think you can do that, and you have to give me an argument as to how this biases the data. But having said that, there's more satellite data than this. We have, for example, data from the East Antarctic ice sheet published by Davis in 2003, and I'd like to draw your attention to the year 2002.5. It's right there. It's the high point of the Antarctic ice record. If it hadn't declined some from then, I would actually be rather surprised. This also is well known, but apparently in the heat of the rhetoric, it is not discussed. It's unpleasant. It's an inconvenient fact. We also have satellite measurements for the sea ice surrounding Antarctica. I don't put lines in data unless the trends are statistically significant. This record begins in 1979, and by the way, because of the orbit of this satellite, that's when the record for Arctic ice begins, also in 1979. The pluses here, this is the East Antarctic ice sheet. Pluses are where it's gaining ice. The negatives are where it's losing ice. And in this paper there was projected a net gain of ice for Antarctica because of increased snowfall. Then the GRACE satellite data came around and showed that decrease, and that's what got all the headlines. This received virtually no coverage whatsoever. But this here is certainly well known about the Antarctic ice. Greenland. Greenland is the scare scenario. That's the idea that Greenland warms up and the ice sheds off Greenland very rapidly, raising sea level up to 20 feet by the year 2100. Try and find that in an article in the refereed literature, when I mean the standard refereed literature, not an op-ed in the journal Climate Change, not a piece that got one review by a friend, but try and find an article or an article based with a model that shows that. You will not be successful. But this is what has infected the discourse. Everybody on one side of this issue believes that Greenland is in danger of shedding all its ice because of the temperature that it's at today, and if we don't do something about it, it's going to happen if we don't do something about it in the next few years. Well, I would ask people to please take a look at the temperature history from Greenland from the United Nations Intergovernmental Panel on Climate Change, because here it is. This record ends in 2005. What you see, this southern Greenland is where the ice is being lost. By the way, the rate of ice loss from Greenland is 25 cubic miles per year. In case that seems like a lot, Greenland has 630,000 cubic miles of ice. The rate of ice loss from Greenland is 0.4% of its mass per century. Not per decade, not per year, 0.4% of its mass per century. Now, if you look at the last 10 years in Greenland, you'll see that the average temperature is considerably lower than the average temperature from 1915 through 1965. That's half a millennium. And in fact, there was a paper published in 1948 by von Allman commenting upon this and the ice loss rate from Greenland, which was pretty substantial at that time. But no one saw anything reflected in the sea level rise records. It just wasn't there. And this continued for half a century. So the obvious point here is people who say that this temperature regime is going to cause a massive melt have missed what happened for 100 years before. This from a recent draft from the new United Nations Climate Report. This shows Greenland losing ice. It loses half its ice somewhere around 1,000 years from today. But please read the fine print, ladies and gentlemen. It says under a climate of constant 4 times the pre-industrial concentration of CO2. That was started at 270 parts per million. We're now at about 380 parts per million. 4 times is well over 1,000 parts per million and is maintained for 1,000 years. Does anybody believe we're going to be burning fossil fuel in the year 2500? I don't know. But I'll tell you this. It would be very hard put to legislate something in the year 1000 based upon what you thought was going to happen in the year 2100. You'd have a pretty tough argument. But it was tried. This is the ice extent in the Arctic in 1979. This is one of the most viewed images. This is by NASA. By the way, if you're actually very clever, you can see that this is Photoshop right here. The white isn't put in the data right there. It's very apparent when you look at it on my computer screen. Then we look at the ice extent from the end of summer in 2005, and we see the loss of all this ice from the Eurasian sector. Wouldn't it be nice if our federally funded scientists told us a little bit about the background behind this, such as the temperature history? Here's the Arctic temperature history from the United Nations Intergovernmental Panel on Climate Change, and I draw you ice melts in the summer to the year 1979. It's at the end of the second coldest period of the 20th century. And in fact, it's as cold as it was back to the early 1920s. What were the news stories that accompanied the first satellite data that came out in 1979? Do you know what they were? It was Antarctic ice dramatically expanded. It was because it was at the end of a cold period and people were concerned about the large expansion of the ice. So it should not be particularly surprising that it declined quite a bit, at least in the Eurasian sector. What's the historical perspective for this? Whoops. This is a hard-to-read graph. This very hard-to-read graph is in the new United Nations report in an easier-to-read form. But I'd like to draw your attention to this red line here. It says Siberia and East Russia, and the legend is more than 2 degrees C warmer than the background. That is from 3,000 years ago to 9,000 years ago. We know this because trees are buried in the bogs all the way up to the Arctic Ocean. Back to 9,000 years ago. The forest went all the way up to the Arctic Ocean. The land went further into the Arctic Ocean because the sea level was lower. And by the way, this is a misstatement. If you read McDonald's paper on this, he says the temperatures in the summer were 2 to 7 degrees Celsius warmer than the background temperature. That is for 6 millennia. Polar bears survived. Read his paper. He's the chairman of the geography department at UCLA. He talks about how the ice had to have been dramatically reduced in the Arctic for all these millennia, and how Atlantic water had to have been getting into the Arctic, which means that Greenland had to have been shedding ice like crazy. Where was the great sea level rise? It wasn't there. 6 millennia. And I hear the argument here that we only have 8 years to do something. Finally, I will close with this. This is one of the assumptions that's made in a lot of climate change research and climate impacts research. I was horrified at the recent document, something in the recent document from the United Nations IPCC, which talked about how climate change is going to cause all these famines and food shortages in the 21st century in Africa. What a pejorative statement. Nations around the world often do not produce as much food as they need, or often produce very little in a bad year. It's what we have something for that we like at Cato. It's called a market. When you don't make it, you buy it. And to say that an entire continent will not develop a 19th century mercantilist economy in the 21st century is something that strikes me as, to say the least, insensitive. Well, are people so stupid that as our cities heat up, they will slowly fry and die? That's another question that has come up because we hear all this subject about urban heating and death. This is a paper we published, Bob Davis and I, on on mortality versus apparent temperature. That's a combination of temperature and humidity. This is New York City. And you can see actually the stickier it gets, the fewer people die, except for these few days here in the beginning of summer where there's a spike in daily mortality as it gets hot and humid. And so the assumption is, because these cities are going to warm up because of global warming, that this number will go on to the ceiling as the apparent temperature goes to about 45 in our urban cores. This, of course, assumes that there will be no adaptation. It assumes that nobody's going to sell a technology. It assumes the political process will not get very, very freaked out when 500 people die in a hot weekend, like they did in Chicago in 1995. The next heat wave that was of similar magnitude hardly killed anybody. Let's take a look at a city that is newer than New York. This is Houston. Anybody been to Houston in the summer? Raise your hand. Why? What's wrong with you? Good Lord. Anyway, what happens in Houston is nobody dies the hotter and stickier it gets because it has the infrastructure. It's an adaptational infrastructure. And so what you see here, if we take a look at CDC mortality data, we had 3 tranches of data. We've been criticized because we only went through 1998, but in fact, because of privacy considerations, CDC would not release the rest of the data. They are giving it to us now for another year so that we can have it into the early 21st century. But anyway, this is the average annual heat-related mortality in United States cities. And now I'm going to tell you something shocking. Okay? These are the mortality plots in the cities, and the heat-related mortality is rare where it's very hot. Gee, I guess people aren't so stupid. Think of the age structure of the population here in Phoenix. You think there are a lot of young people running around Phoenix? I don't think so. How about Tampa? Look, there's no heat-related death in Tampa. I mean, you know, this is not the place where a young lady should go looking for a young man. It's not going to happen. They aren't there. Look at these northern cities, and what you see is the heat-related mortality begins to drop dramatically. There's only one city in which it goes up, and that's Seattle. That's our coldest city. So as heat waves become more frequent, one becomes more adapted. So as you warm things up, as summer warmth spreads north, this mortality will continue to decline. You might say, oh my God, you're going to fry everybody in Canada. Problem is, of course, that once you get north of 60 degrees, there isn't anybody. There are no cities on Earth north of 60 degrees unless they're warmed by something like the Gulf Stream or the Kuroshio Current, or unless they were established by the Soviet Union. How much will it warm? You know, that's not, anything about this, I get all these laughs. None of this is very funny. People actually suffered and died, and the science here is something that may seem strange, but should not be funny. But go ahead and laugh. It makes my day. How much will it warm? Well, easy. We say that the temperature response to carbon dioxide is a logarithm. We say that the increase is exponential, and we give a bunch of computer models. Whoa, wrong way. We give a bunch of computer models 1% per year CO2 increase, and lo and behold, they predict a straight line warming. Problem is we're giving them a 1% CO2 increase. It's less than that. But at least they got the functional form right. So these models are generally predicting too much warming. If you assume the straight line assumption, which is the only thing you can really assume by adding a logarithm and an exponent, you get about 1.7 or 1.8 degrees Celsius warming for the course of the coming century. Now, I offer you the following observation. Before you rush to do something, consider several of the things that you heard in this talk. One, the temperature record keeps on getting colder in the beginning, and the data are not forthcoming. Two, the warming rate that comes out of the models tends to be too warm. And three, you don't really have a suite of technologies that can effectively reduce the temperature trajectory the Earth is on. If you don't believe that, the solid line on here is the average warming for all these models, and the dashed line is the average warming that these models will give you if every nation of the world does what they said they would do under the Kyoto Protocol. 0.07 of a degree Celsius. The world can't do Kyoto. It's just not happening. Oh, we could go around and say we're going to do much more than Kyoto, but you couldn't even do Kyoto. I'll give you an alternative point of view. Instead of wasting money in a futile attempt to get off the trajectory, maybe you ought to save money so people can invest it in companies that produce things efficiently or produce efficient things. Here, automobile company performance for the last 5 years. Toyota, Honda, the S&P 500, General Motors, and Ford. Connect the dots. You know exactly what happened. People took their money and invested in companies that produce efficient things, and they de-invested in those that they perceived did not. They loaned resources for companies to do things efficiently or to produce efficient things. If you took that capital away, in a futile attempt to get off that trajectory, you're going to delay the day in which the cleaner, more efficient future arrives. talk about that in this book. It's a fine book. I hope you all enjoy it. Jerry Taylor's a much better speaker than me. I hand Jerry Taylor the microphone. Thank you very much.
I want to talk to you a little bit about the economics of climate change, which I actually think is as important, if not a more important topic when it comes to climate change policy than the science. Now, this might strike you as odd. After all, most of the debate in the media is about scientists over on this side of the room arguing that climate change ushers in a parade of horribles and a veritable book of revelations unless we do X, Y, and Z. And then on the other side of the room, scientists who argue that the future is not anywhere near so dire as all of that. And the supposition that everyone seems to have is the outcome of that debate ought to dictate what climate policy ought to be. I don't believe that. And the main reason I don't believe that is because I don't think scientists are in a position to intelligently dictate public policy. I think they're in a position to inform the policy discussion, but they are not in a position to intelligently guide our policy efforts when it comes to climate change. Why is that? Well, rather simple. The first thing that you may have thought of when you heard about climate change back in 1988 or 1986 or whatever it might have been is actually a somewhat important observation. When you heard scientists say if we don't do something soon, the global temperature might warm a couple degrees, you might have thought like I did, and so why should I care about that? After all, the observation that the temperature, the thermostat of the planet is perfectly set at where it is today, and any slight change positively or negatively would lead to disaster is a somewhat curious proposition. After all, the Earth's thermostat has changed quite a bit over time. It hasn't led to any obvious disaster. We can go back in climate history and find warmer periods than this one, warmer periods even when mankind was around to suffer the consequences, and it didn't seem so quite obviously destructive to mankind, human civilization of the planet. So what exactly follows from warming? Well, this is where scientists can inform the conversation, but where their expertise is less important than the expertise of economists. Translating observations about what happens to temperature into actual impact on the climate, on the economy, and on the human civilization is a business that is primarily a business for economists, not a business for scientists. They can inform that conversation and give the economists the right data regarding what's going to happen to temperature and sea level rise and that sort of thing, and then they leave the room. And then the economists come in and they translate that into actual impacts. So, have economists actually done this? Yeah, they actually have. There are a lot of very smart economists who've specialized in studying the effect of climate on the economy and on human civilization. And you might be very well surprised at what the consensus of that literature has to say. So, for instance, if you ask yourself the question, what impact will warming have on the U.S. economy, assuming median warming scenarios from the IPCC? In other words, you don't have to listen to Pat Michaels to look at median scenarios coming out of the IPCC and to conclude that if all of that came to pass, that it would have virtually no effect on the U.S. economy one way or the other on balance. Now, this undoubtedly would surprise you a great bit because that's not what we read in the press and that's not what we hear politicians say. That's certainly not what we hear scientists say. But if you look at the academic literature on this, you find this is the overwhelming consensus of opinion from both left and right. It stands to reason when you think about it, only a very tiny fraction of the U.S. economy is affected one way or the other by weather. The largest sector of the economy affected by weather is obviously farming, all of 1.7% of U.S. GDP. Forestry, fisheries, and other agricultural services are also very heavily affected by weather, all of 0.5% of GDP. Those are the two sectors that will be most directly affected by warming. The sectors that will be less affected by warming, but still substantially affected, include the energy sector, 1.2% of U.S. GDP, outdoor recreation, all of 1.2% of U.S. GDP. Coastal real estate, 0.9% of U.S. GDP. The hotel business, 0.8% of U.S. GDP. And water transportation, all of 0.2% of GDP. The rest of the economy couldn't care less what the temperature is. You can build an auto plant in Alabama or in Michigan. You can do financial services work in Manhattan or in Miami. Most of the economy could not care less what the temperature is. Only a very, very tiny fraction of the U.S. economy is affected. And if you look at that list, you'll discover, as soon as you pay any close attention to it, that warming has almost as many, if not more, benefits than downsides for the farming sector, for the energy sector, for outdoor recreation and whatnot. After all, we hear a lot about how ski slopes are going to lose business. Well, certainly true and terrible. I'm a snow skier. That would depress me. But more money is spent going to the beach than going to Alta or going to Aspen or whatnot when it comes to recreational dollars. In other words, the same thing applies to farming. A warmer, wetter climate is actually going to make some real estate more valuable for farming, other real estate less valuable. On balance, in northern temperate areas, it has about a net effect of 0 on the overall productivity of agriculture. It turns out that if you look at the health and mortality estimates, as Pat Michaels mentioned, it's not altogether clear there's a negative effect here at all. In fact, the data suggests that a warmer, somewhat wetter world would actually be a world with less human mortality than a world in which climate was actually cooling. Now, most economists who specialize in this area think that median estimates for climate change in the U.S. suggest that U.S. GDP will be negatively affected by 0.5% of GDP, plus or minus about 1 point of GDP. In other words, there's a large amount of uncertainty. The consensus of the literature is about a negative 0.5% of GDP 50 years down the road. In other words, a relatively trivial effect. And even that is debatable. You'll find economists like Bob Mendelsohn at Yale who will argue that the net effect on the U.S. economy is probably slightly positive. And then you'll find other economists at Yale, like Bill Nordhaus, who think it's probably a little bit more like maybe 0.75% of GDP or something like that. But there's a lot of uncertainty, and there are a lot of numbers, but they all tend to reside in that area of very hard to measure down the road. But that's the U.S. economy. Someone smart in the room might say, well, okay, maybe it's not going to help harm the U.S. economy very much. After all, we're not an agricultural-based economy, but the global economy is worth worrying about. Poor countries rely more heavily on agriculture for productivity. More people are dependent upon that sector as well. So we have to worry about the effect that global warming has on countries other than the United States. True enough, absolutely correct. Now, of course, the biggest salvo in this, the study that most of you have heard about in this arena came out last fall from Nicholas Stern, who was an important economist who was temporarily dispatched to the Treasury Department, and he issued a report called the Stern Review on the Economics of Climate Change. And the Stern Review found that global warming will likely sacrifice 5% of global GDP each year from now until the end of time, an event, quote, on a scale similar to those associated with the Great Wars and the economic depression of the first half of the 20th century. That's a heck of a statement. After all, I've just given you some data that suggests it have virtually no effect on the U.S. economy, very little effect on the European economy. Northern industrialized countries will have essentially the same profile. And yet, Nicholas Stern is predicting global recessions or depressions from now to the end of time from warming. Well, at the very least, this is an outlier finding. This is not reflected by the bulk of the literature. And for those of you who like to bow down to consensus within academic communities, which I discourage you from doing, but if consensus is your mantra, then it requires you to be just as skeptical of the Stern Review as you are of some scientists who you think are outside of their consensus. But anyway, let's not do that, because after all, consensus is nothing. Debates and arguments are won by evidence and data, not by shows of hands. So what did the Stern Review have to say that the literature prior to the Stern Review did not say? Well, it turns out that the Stern Review made 3 assumptions that were at odds with the literature up to this point. First of all, Stern assumed no human adaptation to climate change ever. Mankind will just go about his business and not change his behavior one whit in response to rising temperature. So if you grow corn in Iowa and the temperatures get warmer and the weather gets wetter or drier, depending upon what climate model you want to believe, then farmers, instead of changing the crops that might work better under those conditions, will just continue to grow corn forever until the end of the time. It could turn into a dust bowl and they'll still keep planting corn. Stern assumed no endogenous change of the economy, which is, of course, quite a stretch. Virtually all other studies, of course, assume some degree of human adaptation. Second, the Stern Review cherry-picks the literature. As economist Richard Dahl, a center-left specialist, by the way, on the economics of climate change, has noted, the report embraces without fail every single upper bound damage estimate that one can find in the peer-reviewed or non-peer-reviewed literature. If you find a high number and a high disaster figure, Stern embraces it and plugs it into his report. And Stern dismisses more credible estimates, more mainstream estimates, all without exception. So it's a cherry-picked upper bound study. And secondly, he assumed a discount rate of 0.1% for future losses. Let me explain what that is. For economists, that'll immediately, you'll figure out what the implications of that is. But what Stern assumed is that losses tomorrow are just as troubling, just as worrisome, and just as damaging as losses today. That doesn't sound on its face as particularly outrageous, does it? After all, to say that we shouldn't worry about what happens 50 years from now as much as we worry about what happens tomorrow is essentially to say we don't care what happens to our kids and nobody believes that sort of thing. So what Stern did is he accepted that we care just as much about what happens to our grandchildren as what happens to us. So no discount rate, or actually a 0.1% discount rate. Well, what do we make of that? Well, it actually changes the numbers quite a bit if you assume that kind of discount rate. For instance, if we assume a 4% social rate of return on investment, a 0.1% discount rate suggests that society ought to be saving a full 97.5% of its GDP for the future. Now, would anyone embrace that sort of policy? Well, of course not, because we don't operate that way. We value money and well-being today more than we value it tomorrow. And if we value tomorrow as much as Nicholas Stern believes we should save virtually every single penny we earn for all time. Let's hypothesize, and let's put this in a more tangible context. Let's hypothesize that a wrinkle in the climate system might cause damages equal to 0.01% of GDP a year starting in the year 2200, based on something that we're doing today with industrial emissions. If we accept a 0.1% discount rate, as Nicholas Stern would have us embrace, then society ought to be willing to sacrifice 15% of the world's consumption today to head off this trivial economic event 2 centuries hence. Does that make any economic sense to you? Hopefully the question answers itself. Third, Nicholas Stern ignores the intergenerational impacts of climate change. After all, it's very impressive to say we ought to care about our grandchildren more than we do, and we ought to care about them as much as we care about ourselves, and that's all well and good. But even if global warming were to cut GDP by 10% a year, now remember, Stern's best estimate was about 5% a year, and the economic literature tends to be around the world of 1% of GDP at worst, somewhere, and perhaps much lower than that. But let's assume that it were to cut GDP by about 10% a year. That would mean per capita incomes 100 years hence, under this disaster scenario from Nicholas Stern, in a business-as-usual scenario, would likely be $289,000 per person rather than $321,000 per person, assuming business as usual. Would anyone, let alone the left, ever propose a major tax, which Stern would have us at about 1% of per capita income, or $440 a year in the United States? Would anyone propose a $440 a year tax on those making $44,000, that's per capita income today, to provide benefits for those making $289,000 in real income if this policy were asserted in any other context? Of course not. The point I'm trying to make here is that worrying about the future is very problematic from an intergenerational equity standpoint. If you accept the numbers offered by Stern, essentially, he would have us tax the poor to benefit the rich, and not just the slightly rich, the much, much richer. Well, anyway, what do the rest of the economics community think of the Stern report, at least as far as its assessment of its impact on the economy? Well, there was a recent survey of the members of the American Economics Association last year, in which they were asked to estimate what they thought climate change would do to the economy if nothing was done about it. 20% agreed with Stern's findings, that economic losses would be around 5% of GDP every single year. 21% expected annual losses of somewhere between 1 and 5% of GDP. 36% of those surveys expected impacts of -1 to +1% of GDP. In other words, maybe 1% loss of GDP per year, maybe 1% gain in GDP a year. 36%. 16% of the economists who were with the American Economic Association expected annual gains of somewhere between 1 and 5% of GDP from climate change. And 7% expected gains to the economy of 5% or more of GDP. In short, the number of economists who thought that warming would substantially improve the economy outnumbered the number of economists who agreed with the alarmism of the Stern Review. Of course, again, I don't bow to the idol of consensus, so that's less persuasive to me than it might be for those people who do. But it does show you how far out of the mainstream these disaster scenarios are when it comes to the people who are studying this stuff for a living. And by the way, most of the economists who are engaged in this for a living are not people who would be senior fellows at the Cato Institute. Bill Nordhaus, for instance, who's probably one of the most prominent academics in the United States who specializes in this, was an informal advisor of the Clinton administration during the negotiation of the Kyoto Protocol. It is not someone who normally would be in the cover of Cato Journal. So these are not economists at ideological axes to grind. Anyway, just for the sake of argument, let's accept Stern's analysis about the cost of global warming, but instead of applying his 0.1% discount rate, let's apply a standard 5% discount rate, which we might apply in virtually any other context. In a world with no doubts, 50 years of costs, 1% of income, followed by 100 years of benefits, 5% of income, passes a cost-benefit test just barely. $8,100 of cost today in taxes to head off to gain benefits of $10,000 or so a year. In other words, What Nicholas Stern is doing is assuming that the best policy in the world is a policy which reduces global warming at a cost of about 1% of per capita income. If you assume that and apply a 5% discount rate, you barely pass a cost-benefit test if you assume the scenario that I just described. But if global warming doesn't hurt the economy by a rate of about 5% of GDP a year, let's assume it only hurts the economy by about 1% of GDP a year, which seems to be a much more reasonable estimate, then Nicholas Stern's proposed policy would cost us about $8,100 a year in present value to produce benefits of only about $2,000 in present value terms. In other words, it doesn't really pass a cost-benefit test to do much about global warming, even if you accept Stern's estimates about the impacts of climate change, but apply, say, a more reasonable discount rate for that figure. Now, even that doesn't really tell you the whole story, because what's not included in these estimates are some tangible direct costs associated with global warming and fossil fuel consumption that rarely find their way into these calculations. For instance, the United Nations has reported that about 2 million people die every year because of indoor air pollution around the world. Well, how is that? These 2 million people are dying because they don't have electricity, because they're burning biomass for heating and for cooking needs without electricity. That causes a tremendous amount of indoor air pollution and results in death for 2 million people every single year because they don't have electricity. To do anything about global warming, it requires us to do something about fossil fuels, to make them more expensive or to run them out of the market. Making fossil fuels more expensive will make it more difficult to remedy the problem of indoor air pollution in the third world, a problem killing 2 million people every single year as we speak. That is a direct cost of doing something about climate change, which is seldom discussed. I can guarantee you that if we knew with certainty that 2 million people were dying every year on this planet because of global warming, there would be suicide bombers going at the White House today. But the fact is we have 2 million people dying from poverty-related environmental causes every single year, but from a less sexy cause, lack of electricity, lack of affordable electricity. And doing something about climate change would actually make that problem more difficult and not easier to solve. Higher fossil fuel costs also will slow the general march out of poverty. And not only is poverty the number one killer on the planet, it's also the number one cause of environmental ruin. You can find this in the literature no matter where you look, whether you're looking at left of center or right of center perspectives. Deforestation, habitat loss, air and water pollution are all very strongly correlated with per capita income. Anything which makes us poorer will make the planet slightly dirtier and will harm all sorts of other environmental goods and services that we hold dear. So what do I take from all of this? What do I hope you take from all this? My proposition is that public policy ought to be able to pass a cost-benefit test. If someone is proposing a bill, it ought to produce more benefits than the costs. That seems relatively straightforward. I know that that's a controversial thing to say in Washington, or at least there are a lot of people who disagree with that. I've always found that just amazing. What, you mean benefits should not outweigh costs? You mean costs should be greater than benefits and that wouldn't bother you? Of course, what bothers people is that they don't trust these cost-benefit tests. And they see this as an obstacle to reform or obstacle to good public policy. But it seems to me that the remedy for a bad cost-benefit test is a good cost-benefit test. But you definitely want public policy that does more good than harm. How would we look at that in the climate arena? Well, for any given piece of public policy or legislation, I would suggest that you ask sponsors to quantify the extent to which this policy, if fully implemented, would reduce global temperature. Seldom is that question ever asked. If Barbara Boxer has a piece of legislation to reduce greenhouse gas emissions, someone should be able to ask, well, how much lower will temperatures be if we pass your bill? Next year, 10 years from now, 50 years from now, 100 years from now. Can it be quantified? Because that's the benefit associated with legislation. At the end of the day, that's what we care about. Now, if you were to quantify that benefit, you would then compare it with the cost and see where you stand. I would suggest that it's virtually impossible to find climate change legislation in the United States where the benefits of that legislation outweighs the cost. That's particularly the case since U.S. greenhouse gas emissions are an increasingly small part of the global problem. A study just came out last week from the IEA which found that if current trends continue, China will emit more greenhouse gases in the year 2025 than the United States, Europe, Japan, all other OECD nations combined times 2. In other words, this is a problem that if it is to be addressed, if we ever decide it needs to be addressed, is a problem that has to be addressed at a global level. It's not entirely clear to me, based on the numbers that I offered you, that it's worth addressing. that the costs associated with climate change are anywhere severe enough to warrant the kinds of policies that would be necessary to do much about it. Now, the final thing that most people will say when they hear all this is, well, that may very well be true, but shouldn't we take out an insurance policy? I could be wrong. Climate change could be much more serious than we think. And after all, we take out insurance policies for lots of things. Even if a policy can't pass a cost-benefit test giving standard assumptions about the future, there's always a chance that the future will look differently than what we suspect. So what's wrong with that sort of climate policy? Well, there's nothing wrong with that line of argument. But remember what we're talking about here. We're not talking about taking out an insurance policy that would stop global warming. No one can do that at this point without totally abandoning fossil fuels come next Tuesday. What we're talking about are public policies which will slow or reduce the amount of warming we're going to see in the future. This, by the way, isn't a particularly radical thing to say either. Believe it or not, a fishing friend of mine is a guy named John Pescandano, the head of Greenpeace USA. He lives about a mile from me, and believe it or not, he likes to bass fish on the Potomac, something I like to do too. So we go out upon occasion on this. And even John, I'm sure, would tell you in public what he tells me in private, which is, of course, we can't stop global warming. That will not happen. What we're talking about are policies that might slow down global warming, that might minimize it a bit or make it more manageable. So that's the kind of insurance policy that we're interested in buying. Question, what is the best way to insure against that sort of thing? What's the best way to secure a moderated global climate change or one which has less impact? I would suggest the best way to do that is provide for social wealth. After all, climate change will have very little impact on the United States for a very good reason. We're a wealthy, advanced industrial civilization. We're very productive. We grow a lot on an acre of land. We have a very advanced economy which doesn't live or put people in a position of living in what is the equivalent of the 17th or 18th century. The best way to minimize and put a boundary around the damages that might be associated with warming is to provide for economic growth, economic opportunity, wealth creation, and the ability to adapt and mitigate against any harm that we might run across. I would think that would be the best sort of insurance policy we could have. That's an insurance policy, by the way, that isn't going to be secured through carbon taxes or running coal out of the economy or running oil out of the economy. It's going to be secured through pro-growth, wealth-creating policies. That, I think, is the best public policy for addressing global warming and the best insurance policy to make sure that warming in the future will not be anywhere near as dire as a lot of scientists fear that it could.